It's been a while since we talked. We just last time we spoke about how to build our own Linux kernel. So after playing with lead code algorithms, Linux kernel, I thought I'll introduce you guys to a new topic today, which is the Zephyr RTOS. So we have never talked about RTOSes actually. So why we need Zephyr RTOS, or what is the advantage of Zephyr RTOS over other RTOSes, and what's the bare metal code? Maybe we'll create a video on bare metal soon. If you guys want to hear more about that, please feel free to comment, post your comments in the under the video, and maybe we'll try to create a bare metal next time. So now we are going into the RTOS territory. So how do you start with Zephyr RTOS, and what is the Zephyr RTOS? It's a very small footprint RTOS that started from Linux Foundation, and it has some of the smell and feel of Linux, in the sense it has like device trees, things like that. So you can get a lot of information about it on the website. For example, how to what are the dependencies you got to have. So it says here in the website, if you go to the docs.zephyrproject.org, it tells you got to have CMake, you got to have Python, you got to have device tree. So these three things you got to install: CMake, Python, and device tree. And it even tells you how to get these things from different websites. So on docs.zephyrproject.org, you would have a getting started guide, and there will tell you what versions of CMake, Python, and device tree you need and how to get them. So after that, you need to also have install Zephyr itself, and most important thing is the Zephyr SDK. So the SDK you need to basically build Zephyr. So it tells you after Python, I think, and then there's a Zephyr build package which is known as Vest. You got to get Vest, very important how to get. So it tells you actually, once you have the Python, it will tell you how to install, how to get Vest. So you see it's telling here how to install pip install Vest. So pip, as you know, is the Python's installer, and then once you have the Vest, you can get the Zephyr source code. That's what it's saying here. Zephyr init, the Vest init Zephyr project tilde is your home directory, and then it says cd there and says Vest update, and then there are like bunch of other commands like how to export a Zephyr CMake package in the Vest. So that you can just follow these, and then you can get the Zephyr SDK, and that he tells you here very clearly how to get the, go to your home directory, cd tilde, and then wget. He use the wget command to get this Zephyr rtar.xg file, and then he extracts that, and after extracting that, you pretty much have, and then you have to go to that directory and run the setup script. And the other thing is that he says if you want to flash, what is flash? Flash is most likely you would do your Zephyr RTOS build for a particular board. So what's your RTOS board? In my case, I have STM32405, which you can get from Amazon for like less than 40 bucks, maybe 30 bucks, maybe 25 bucks. And if you go to some other websites, it's even cheaper. If you go to, for example, DZ or Mouser, or even like, for example, AliExpress or something, it's even cheaper. So mine is STM32F. 405. I will post, you would see later in the video how to get the how does the board look like, and he says, so that's what. So that's for flashing means how to get your build, your a dot out. There's no a dot out in this case. They call it a dot out in C or when you're running your code on Linux, a full-fledged operating system. But here there's no a dot out in the sense that you will have one dot bin file that you need to flash, kind of burn into the board. So he tells you these other steps if you want to. I think I didn't have to do something like that. In any case, I don't know this, but anyway, build the blinky sample. So how do you build the blinky sample? So I'm going to show you how to do that. So in my case, as you can see, my my Zephyr project, Zephyr is set up here, and if I want to, for example, do a west. So for example, first, this is very important command, west build. In fact, he mentions it here. Look at that. I'm not doing anything special if you think about it. Only thing different is you got to know what is your board name. In my case, as you can see, I'm giving the board as STM32F4 underscore disco. Disco is for discovery basically. STM32F405 discovery. I think it's not 405, it's just 407 VG or something like that. Yeah, I don't think it is 405 discovery, but they're more or less the same boards with like similar configurations. So in this case, since my board is F407 VG or something, and for that you have to use STM32F4 disco. So if you see, I'm going to do the I'm going to bring very basic version first. So before that, I also want to show you what I have. I have CMake 325. I have Python, I think. Let me show you. Yeah, I have Python 385, and I have DTC 140. So these are all the required dependencies before you even need to get Python and the Zephyr and the Zephyr SDK. So, and then as you know, my home directory, as you can see here, is my Zephyr project home directory, and the packages that I'm going to build, for example, if you go to cd samples basic blinky, this is the most this is the basic, most trivial program basically you can build, sample you can build and burn it to your board. So what we're going to do is we're going to come back to our root of the Zephyr project, not the root of the OS where we installed Zephyr. After that, we're going to do a West, using West that we just talked about. We will build one of these packages, basic blinky, and we can actually do from the root. So you see here I'm saying West build and build is basically one of the command. -p is saying pristine, meaning delete everything in the build directory that you had, start from scratch, and -b is telling you board, and this is the sample that you want to build. So if you go to that directory cd samples basic, you would see bunch of examples, one bunch of subdirectories, and one of the subdirectories will be blinky. And how do these, before I even, okay, let's build first and then we'll go and check, because my environment is all set up. As you can see, it is the build, it is going through the build, West is going through the build. You can also use CMake directly to build these, so it's not necessary that you have to, if you're not comfortable with this West and what is this whole West building is. Well, a lot of companies I know, they go straight for CMake and don't care about West at all. So if you want to build from CMake, it will be something like this: CMake, like this, CMake minus D board equal to West, and then I will come to this later. But right now I want you to introduce you to the how do the samples look like. So samples basic, what did we really build actually? Where is the source code, you might wonder, right? So you see here I have bunch of directories like blinky. What is blinky? Now all the source, the samples would have the same format, in the sense in all of them you would see a cmake list.txt, you would see a source directory, That's where your source actually is. So let's look at what is the source in Blinky. There will always be a main. So you can think of this your main as like your C programs in Linux that has a main where the code or the start.s, basically the set vector after setting everything, uh, it will basically jump to it. So you can think of, if you don't want to know about what happens before the main gets started, it's good to know that the main, your code will get to run if you have a main. So you see, all he does is he basically brings a LED, and then he sleeps for sleep time ms. I think he defined it somewhere over there. Yep, sleep time ms is 1000. So that means he sleeps 1 second, and then he's basically so that is why so that's how you can get your first sample built. So that's where the source code is in all of these samples. So we can go to one more and see the format. Let's say we go to threads this time, right? So in threads, go to same pattern. You see cmakelist.txt, which basically tells you the where to find the Zephyr sources, and find package target sources. See, that target sources line is very important. You're saying that's where your action starts. So source main.c. So you go to source and you see main.c, and then here in this case he has actually bunch of threads, and these threads basically, you see blink 0, blink 1, and there's much more going on here. You got threads, not just, so you see here in the main, you definitely need a main. So when your main is called, let me see, is there a main here or not, or this, or you know what, in this case I think what will happen is your these threads, k thread define, the threads get invoked, and blink 0, blink 1. So but I was wondering that there should have been probably a main still. So while one blink, okay, a generic function, bunch of device trees and those things, we will come to that in another video. But if you see in source, we are calling it main.c, but I don't see a main function. Maybe the control goes to this these threads, but how? K thread define, blink 0, blink 1. So we'll solve that mystery in one of the videos later, or if you know already, you can always post it in the link under the video. But right now it's very important to understand how to build this and how to start going. And once you get going, then you can always, you can keep exploring day in day out. But right now what is important is this directory structure and how the packages are installed and everything. So you see, source is where the sources are, build is where the build happens. So there, if you go to Zephyr, and then you go to, you see here Zephyr, that .elf file, that's the one that gets burnt to the board. See the Zephyr.elf? So that's your kind of a.out equivalent of, but that's the one that gets. So when you say, for example, because we did Blinky at this point, right? We just let's build Blinky again. So after we build Blinky, how do we get this built elf file onto the board? So we have to say west flash, or there is another way to flash these. If you have the STM microelectronics, the boards, the manufacturer of the board will probably tell you other ways to flash it on the. So for example, now in this case, if I do a west flash, look at what happens. See, so you got, so basically whatever you did, whatever changes you made, it got flashed. And one more thing I want to show you here is the how to connect to the boards. When you get more advanced, or at least intermediate level, you might want to have to see the console or this UART printout coming from the board. and they usually happen on bunch of GPIO pins. In this case, I have it connected on UART3, which is PB. If you look at the board later when I show you the board, it will tell you PB 11 and PD8. The white is the white your wire goes into the cable, goes into the PD8, and PB11 has the green cable, and the black is connected to the ground. You end up getting a console. So what is the idea of the console? So let's see, control shift, I think it's a control shift A or some, yeah, control shift A, control A G, okay, yeah, there you go. So control A G. So I'm running minicom, and minicom is basically, for example, I can quit right now. If I say quit, okay, there you go, leave without reset, yes, okay. So now as you can see, I have minicom on. So once you connect the UART cable to the your serial to, is a serial TTL converter. Basically, it's, you can call it USB to serial cable, which you can easily get for a couple of bucks from one of these sites like Adafruit or and these Mouser or like DigiKey. But once you connect it, you should start seeing a new device appear. If you look at your D message or something, I'm running on Linux, it will tell you, hey, I discovered a new device, TTY USB 0. So you got to open your console on that port. Now because of the Blinky running, you don't see nothing coming on the console right now because Blinky is just blinking, right? And blinking, how it does, you can see the way it's blinking is, you see every 1 second whatever this. Now you can, in this Blinky, what is left at your discretion is that you can probably go to see again there, go basic, sorry, CD samples, basic, Blinky, and then maybe you can, once you can, once you get at least one time, once everything is set up and you are able to do West Flash and you're able to see it blinking, then maybe next first time, just as a to see that your code is working and you're making some, so your changes are taking are going into action, you can change the sleep time from 1000 to maybe like 2000, so it becomes 2 seconds, and then you can see, oh, it is blinking every 2 seconds, so things like that. But in any case, we want to see the output on console on serial table, so serial cable. So what we're going to do is, we'll go back here and we're going to build a new package this time. We won't say Blinky, we'll build actually, uh, we are going to build, for example, this sample threads instead of Blinky. So you see, instead of Blinky basic, we're going to build threads. So you see threads, and after that we do a West Flash, and we should see some output on the serial cable, because in our this threads samples basic threads package app, we call it app actually. The Zephyr's terminology is to call these samples as apps, and in these apps usually have main or threads or things like that. So that a app actually has something going on the UART console. So now if you see, if I do a West Flash, what happens? West Flash. See, as soon as I did a flash, you started seeing these other output. So in this case, I have couple of not just manipulating one LED. I'm actually manipulating two LEDs, and there's even a counter going. And this is, I was hacking. When I was hacking, I wanted to see if an ISR is getting called or not. So I put some code in ISR function to see it's not getting called, but that's fine. You can see the LED is getting toggled. And what's going on, where they are coming from, as I just showed you that in the samples basic threads, you see when you go to source main.c, there were two threads. You remember there was a blink 0, blink 1. You see here, here thread define blink 0, blink 1. And what do these blink 0, blink 1 do? They basically blink a blink the LED, and then they actually there are three threads. There are two threads that blink, and there's one thread that actually prints says toggled. See here it's saying toggled, and that is why you're seeing this toggle on the serial console. So I hope it was useful to get. Important thing to understand is that you got to have three things before you start having Zephyr. You got to have CMake, you got to have Python, you got to have DTC, then you got to have Zephyr, then you got to have, then oh sorry, before that you got to have Vest, and Vest will let you install Zephyr, Vest in it. You see the place where he said install Zephyr. This was, see here, Vest, get Zephyr. So Vest in it, when he said Vest in it, tilde Zephyr project, see here, and then cd tilde Zephyr project Vest update, and then couple of more steps. So you got Vest, then you got Zephyr, Vest got you Zephyr, and then you got Zephyr SDK on your own by doing a wcat or SFTP or whatever you want to do, and then you can extract, and then you know how to burn. That is using the that is basically using Vest, how to build any application. If you want to make changes, you want to see a different printout on console serial, you can modify in your source main.c files, and then you can do a Vest flash. And in the next video we will use a bare metal code, bare metal, maybe we'll have a bare metal video soon. Then we'll talk more about what if I don't have Zephyr and I don't have Vest, then how do I flash. So we'll use ST's own utility like ST flash, which will tell you where to flash, the address, and it will do the flash for you. So I hope it was useful, and I just wanted to give you a quick intro of Zephyr project, and I will see you in the next video again.